Hello everyone. Hello and welcome to today's session of the AWS Cloud Security User Group West Africa. So thanks very much for joining us all today. So I can see we have quite a few people that have already joined. So just a quick reminder before we go ahead, if you're yet to um, subscribe to our YouTube channel, what are you waiting for? So, and also if you're yet to like this video, make sure you do so. So that always helps. Um, so there's some internet connectivity issues that's going on with Satrigo's connection, so it's not able to join in terms of the moderation yet. So, but what we'll do is I will go ahead and get started because of time, so we can finish on time today. So let's get started with today's session. Let's go. Okay. Oh, okay. So let's see. Let's see if we can bring Satrigo in. Hello, Satrigo. Hello? Hello, Satrigo. Are you there? There's still a lot of background noise, so we can barely hear you. There's a lot of background noise, so we can barely hear you. So we'll come back. Okay, so we'll come back to Satrigo once everything is ready. Okay, let's go ahead and get started for today. So today we're going to be looking at secret management on AWS. Secret management on AWS. And this is going to be a very interesting session. So we're going to be looking at three main services today. So what services are we going to be looking at? So we're going to be looking at AWS KMS, of course, AWS Key Management Service. So this is a service that we can use for managing keys in AWS. So we'll have a look at some information that you need to be aware of if you're planning to take the AWS Security Specialty Certification exam. So these are critical information that you need to know before taking the exam. The next service that we're going to talk about is we're going to talk about Cloud HSM. So this is another key exam objective that you need to be aware of. So we'll go over that service. And then finally, we'll look at the service called Secrets Manager, which is a service that we can use to manage the life cycle of secrets in AWS. And as we go through this, if you have any questions, put your questions in the chat window, right? And we'll be happy to address your questions. So, and remember that at the end of this session, we're going to be having a quiz. And we're going to be giving out 2 prizes today because yesterday there wasn't any quiz. So the prize from yesterday was moved to today. So the top 2 scorers for today are going to be receiving prizes. Okay, so let's get started with today's study session. So what are the objectives that we're going to be looking to achieve in today's session? Well, we're going to be looking to understand how key management and how data encryption works with AWS Key Management Service, with AWS KMS. We're going to be looking to understand how AWS Cloud HSM works, right? How we can use it to generate keys, how we can use it to secure keys. And then we're going to be looking to understand how we can use Secret Manager to authenticate our applications and also to get access to secrets that can be used to authenticate to third-party services. So that's what we're going to be looking to achieve today by the end of today. So let's start first with KMS. Well, before I talk about just KMS itself, I wanted to just give an overview of just encryption in general. So what exactly is encryption? Encryption is, to put it very simply, it's a process where we take a plain text. Plain text is information that's clear, right? That's usable, that's immediately usable. We'll take that plain text, we apply some form of cryptographic calculations or some form of algorithmic calculations on it, and we get the end result is we have something called a cipher text, right? So that is encryption. You take a plain text, you apply some mathematical calculation on it, you get a ciphertext. That ciphertext cannot be understood, right? So it's mangled. In order to be able to understand that ciphertext, you need to go through a process. So this is the encryption process. You need to go through a process called the decryption process, where you have to decrypt this ciphertext back to plain text. And there are two main types of encryptions that you're going to see around. So there's encryption, which is called symmetric encryption. And symmetric encryption uses a single key, uses one key. So it's going to use a single key to perform that mathematical calculation to convert that plain text to a ciphertext. And then we have another type of encryption, which is referred to as asymmetric encryption. And asymmetric encryption uses two keys, right? So one of the keys is going to be a public key, and one of the key is going to be a private key. And the idea behind that is that whatever we encrypt with the public key can be decrypted with the private key. Whatever we encrypt with the private key can be decrypted using the public key. So that's the whole idea behind that, right? So, and what you typically see is that it's a combination of both symmetric and asymmetric encryption that's used in many scenarios. Right? So, for example, if you've ever gone to a website that's using HTTPS, where you're using TLS encryption, that's using both symmetric and asymmetric encryption. So, what it's going to do is that it's going to generate a symmetric key that it's going to use to encrypt the back and forth conversation between the client and the web server. However, it's going to use an asymmetric key to protect this symmetric key, or to protect the initial transfer of this symmetric key. So the reason for that is because asymmetric encryption uses a lot of compute power, so we don't want to be using it all the time. So symmetric key uses less compute power. So we're going to fall back to symmetric key, but we're going to use this to start the process and to exchange the symmetric key. So just wanted to give a quick background information around that before we get into this conversation. Okay, so when we are talking about managing these keys that we are using for encryption, the symmetric keys, the asymmetric keys, there's a lot of management overhead that's involved here, right? So a lot of management overhead that's involved in terms of managing them. There's a lot of overhead that's involved in terms of importing them and rotating the keys. So because most times what we want to do is we want to make sure that the key has a life cycle that we can regularly rotate, right? There's something called time-limited security, right? So you have the same key for a long period of time, you're increasing the chances that could be compromised. So you want to keep rotating your keys every now and then. So defining the usage policies for the keys, who can use the keys? What can they use the keys to do? All of those are additional management activities that we have to think about. Now, where are we going to store our keys, right? How do we physically secure where we're going to store our keys, right? What about the hardware that's going to be used to store our keys? Is that a well-managed hardware? So these are all the things that we typically need to handle by ourselves. One of the good things is that AWS has a service called KMS that can simplify this for us. So let's get started by looking at what KMS is and understand how it works. So KMS, what is it? It's a managed service that we can use to do three things. We can use KMS to create encryption keys. We can use it to store the encryption keys that we've created, and we can use it to manage the life cycle of the encryption keys. So those are the three things that we can use KMS to do. So for storage, for creation, for storage, and for management. So, and KMS uses a two-tiered key hierarchy. So using something called envelope encryption. So we'll talk about that in the next slide. So this will make more sense to you. So we can use it to centrally manage our keys. We can use it to secure access to our keys. And we can use it to determine who can use keys with usage policies. So we can use KMS for all of this. So one of the things just to keep in mind is that KMS is a highly secure service. It's also highly compliant service. So it meets the compliance requirement for many financial organizations. So it meets the financial requirement, for example, for the FIPS 140 level 2 compliance requirement. So KMS meets this compliance requirement. So I mentioned earlier, or mentioned on the previous slide, we said KMS uses a two-tiered key hierarchy for encryption. What does that mean? Let's have a look. So with a two-tiered hierarchy encryption using the envelope encryption, here is how it works. So let's say I have data in the S3 bucket that I want to protect. I need a key that I'll be using to encrypt that data before storing that data in my S3 bucket. What we can do is we can have a key, which is called the data key, and this is the key that we're going to be using to encrypt the data. We're going to use this key to encrypt our data. Whenever our application needs to encrypt any data, it can make a call to KMS, retrieve this data key, and then use it to encrypt the data, right? Before storing that data in S3. So now we have encrypted data that's been encrypted with that data key. However, we need to be able to protect this data key. We need to be able to secure that key. So how do we do that? So what we do is we introduce another type of key, which is where the two-tier hierarchy comes in. So the other type of key is called the customer managed key. The purpose of this key is simple. Its purpose is to protect this data key. So the purpose of this data key is to protect the data. The purpose of this other key, the customer managed key, the CMK, is to protect this data key so that this data key is also always encrypted, right? So that's the whole idea of the two-tier hierarchy. So this whole process is referred to as the envelope encryption. A few information about this customer managed key, the CMK, a few information about this key that you need to know if you're planning to take the exam. This key can either be managed by the customer managed, or this key can be managed by AWS managed. So we have the option to whether we want to manage this key ourselves or whether we want to let AWS manage it. Right. So just keep that in mind. The other thing to also keep in mind is that in some situations, you can also use the customer managed key. You can also use it to encrypt data, even though that's not common. But it's possible to use this key to also encrypt data, right? So normally you can use it to encrypt or decrypt data for up to 4 kilobytes. So because the data key is usually very small, so you can use it to encrypt or decrypt data up to 4 kilobytes. So some other information to also note about this whole process. So I said it can be customer managed, it can be AWS managed. So if it's AWS managed, you get certain features that AWS takes care of for us. So for AWS will automatically rotate that key, automatically rotates the key. If we're managing it ourselves, which is to manage it ourselves, so we have to either enable rotation or we need to take control of that rotational process. So we'll talk about that further in other slides. So let's move on for now. So AWS KMS functionality, what can we use it to do? Well, we can use it to create the primary keys with unique alias and description. So the primary keys, you can also think about that as the CMK, by the way. So you can also think about that as the CMK. So we can use it to create CMKs and then give it a unique alias. An alias is just a friendly name. So it's just a friendly name. So I can create, maybe I create a key, I call it, maybe data encryption key, and that will be the friendly name that I'm going to use. So whenever I want to use the key, I can refer to that alias which is referring to the encryption key that I've created. We can implement automatic rotation for our keys. So we'll talk a little bit more about this in other slides. We can disable keys, we can delete keys. So if you're looking to maybe stop using certain keys, the best practice is not to go ahead and delete the keys. Because if you delete a key and the key is still being used to encrypt some data, you could lose access to those data. So that's why you have like a two-step flow that you can implement. So if you want to retire a key or to deprecate a key, what you can do is to first of all maybe disable the key, make sure nothing goes wrong. At least if something goes wrong, you can go ahead and re-enable it again. And once you're sure that no one is using that key, then you can go ahead and you can delete the key. So you can go through a two-step process. Another important KMS functionality is that it's audited using CloudTrail. So all the different activities that we're performing in terms of creating the primary keys, key rotation, accessing the keys, all of those are going to be stored in CloudTrail, where we can access all of those logs. And we can use those logs maybe to investigate certain issues, or maybe just to review the activities that have happened in KMS. We can import keys also into KMS. Again, we'll talk about those in other slides. So let's move on. Let's talk about protecting keys. When we have an instance of KMS, how do we give people access to our keys in KMS? What options do we have to give people access? Well, we have three options. Option number one is to use IAM policies. And that's the same IAM policies that we've talked about in this series multiple times, and that many of you probably know. You go to the AWS IAM service, you select a user, a group, or a role, and then you define the permission that that user, group, or role is going to have to KMS. So that is one option that we have. Option number two is to use something called resource-based policy. So resource-based policy is where we configure the policy on KMS itself. So only a few services in AWS support resource-based policy. KMS is one of those services, right? So we can either use IAM policy or resource policies to define who has permission to access the keys that we have in KMS, right? But there's a third option that exists that we can use to grant access to keys in KMS, and that third option is referred to as grants. Okay, so David helped me to understand what's the difference between policies and grants. When do I use policies? When do I use grants? Grant is mainly used as a delegation mechanism. What does that mean, David, by delegation mechanism? What are you referring to? Delegation is where I want to give somebody else permission to grant access to other people to the keys in KMS. So instead of me going to IAM and saying I want to grant, David permission to this, right? What I'm going to do is I'm going to give, Lukman the permission to grant permissions to other people to the keys in KMS. So they don't have to be coming to me all the time if they want access, right? Lukman can assist them and give them whatever access that they may need. So this is mainly used in temporary permission use cases. So Lukman can grant permission to them. Lukman can revoke the permission to them without having to modify any policy. But also, grants allows us to set more granular permissions than what policies allows us to set. So, for example, grant allows us to define the permission per key on an individual key level, where I can say this particular key, I'm giving access to you to be able to read this particular key. Right? And there are certain permissions that we need to grant Lukman if Lukman is going to be able to do that. So, for example, in IAM policy, I can grant Lukman the permission for KMS, maybe create grant, or KMS revoke grant. And both these will give Lukman permission to create grants for other users and also to revoke grants for other users. So just keep that in mind. When do you use grant? When you want to delegate permissions, when you want to delegate who can grant permissions, when you need more granular permissions, right? So it's about delegation. When you need more granular permission, you use grants. Other use cases use IAM policy. So let's talk about like the next one. What about importing keys? I mentioned earlier that when we're working with the customer managed key, the CMK, which is primarily used to encrypt the data key, I said that CMK, we can either have the key to be customer managed or the key to be AWS managed. One of the advantages if we're using like the customer managed option is that we can generate our keys outside of KMS and then import that key into the CMK, into the customer managed key. So it allows us to be able to use our key. So in this particular case, in our corporate data center, we've generated the key material there, and then we import that into CMK. And what that means is that we have greater control over the life cycle of that key because that key is in our control, right? So we generated it outside of KMS. But in some cases, maybe it allows you to meet certain compliance requirements. Maybe you have certain compliance requirements in terms of how you should generate your keys, right? So now this allows you to go generate your keys in a way that meets your compliance requirements and then import them and use them. This is what that interface looks like. So in this case, as creating a CMK, customer managed key in KMS, it says to me, it says, hey, the key material that we're going to be using, do you want KMS to generate it automatically for you? Or do I want to select the external option? If I select the external option, then I'm able to go generate it somewhere else and then import it into the CMK. We'll talk about this option when we talk about cloud HSM. So what about rotating keys? How does that work in KMS? For us to understand how rotating keys work, let's take a step back to understand, what the structure of a customer managed key in KMS. When we create a customer managed key, remember this is the key that is used to encrypt the data key, right? When we create a customer managed key in KMS, we have different informations that are created, but primarily we have two things that are created when we do that. Number one, we have a key identifier. A key ID is created, right? And number two, we have the key material. The key material is the actual key that's going to be used to encrypt the data key. That's the actual key. However, the key is linked to an ID, a key ID. So why are we talking about this? Because this is what helps us to understand how rotation works. So when we talk about rotating keys in KMS, what we're rotating is what is referred to as the key material, which is also referred to as the backing key, which is the key itself. So we're not rotating the ID. So the advantage of that is that if a client application is using that key ID, they're always going to be referring to that ID. The ID does not change, but the key material that's used to perform the operation, we can keep rotating that and keep changing it to a new version without affecting the application itself, right? So that's the whole idea behind that. So by default, for a customer managed key, key rotation is disabled by default. Keep this in mind, it's disabled by default. However, we can choose to enable it if we want. It's disabled by default, but we can enable it if we want. If we enable it, how often can we get it to rotate? Well, keep this in mind also. We can get it to rotate every 1 year. Every 365 days, we can get it to rotate. David, set it for something smaller than that. No. The lowest you can set it and the highest that you can set it is 1 year, 365 days. That's it, right? So that's what. David, What if I need to be able to rotate it more frequently than 1 year, 365 days? Well, we talked about the option you can use earlier. Use an imported key then that you control. Then you can control that if you want to control that. So that's sort of like the option that you have. So use an imported key that you control. So if you're going to be using an imported key that you control, this is how your rotation process will look like. Number one, you create a new CMK and then point the alias. Remember that an alias just means a friendly name for the key, right? And then point the friendly name to the new key that you created. So you are responsible for that process if you're using an imported key material. So create a new CMK, import the new key material into it, point the alias to the new key if you're using aliases. And then you can go ahead and you can then update the key policy of the old key so that users or applications cannot use that key anymore. And then after a while, you can disable the old key to ensure that no one is actually using them. And then after a while, you can go ahead and you can delete the old key. So that's the process that you have to go. But if you're going to be going for the option where AWS manages that for you, and you're not using imported key material, that's 1 year that you can set that to. So here's a good quick example of AWS KMS in action being used to encrypt an EBS volume. An EBS volume is just like a virtual hard disk in AWS. Essentially, block storage is what we're talking about. So, excuse me. So in this particular case, we have a data key, of course. The data key is been encrypted with a CMK, right? So CMK is being used to encrypt the data key. And then we have encrypted data key here. So the first thing that happens is that EBS retrieves the encrypted data key EBS retrieves the encrypted data key in KMS, and then it's going to store that encrypted data key in the EBS service, right? So it retrieves the key that it's going to be using to do the encryption, and it's going to store that in EBS. So you notice that key does not leave, in this particular case, the key doesn't leave KMS in plain text. That's another thing to also mention. The CMK, which is the key that's used to encrypt the data key, you can't export it outside of KMS, so can't be exported. You can implement backup, but you can't export it outside KMS. So just keep that in mind again. Okay, so number one, the encrypted data key is retrieved and stored in EBS. And then the EC2 instance in this case, so that's being used by an EC2 instance. The EC2 instance that needs to use the EBS volume, it's then going to retrieve the data key, and it's going to retrieve the encrypted data key from EBS service, and then it's going to make a call to KMS to decrypt that key. KMS is going to decrypt the key using the CMK, and then it's going to return the decrypted key back to the EC2 instance, who can then use the decrypted key to decrypt that EBS volume. So that's how the process works. So get the encrypted key, and then the EC2 instance retrieves that encrypted key, makes a call to KMS to say, I have the right permission, can you decrypt this key? Key gets decrypted, passed to the EC2 instance, which loads that into memory, uses that to decrypt the EBS volume. So that's sort of like the flow to that. David, when this key is decrypted, can it not be intercepted along the way? Because now the key is in plain text. So the channel between the EC2 instance and KMS, that's a secure channel, right? So that's a secure channel. So that's going to be using TLS encryption. So it's not, even if it's intercepted, it's going to be encrypted while it is in transit. Okay, so let's see if there's any questions before I go on to the next one, where we talk about cloud HSM. So let's see. Sachugo, are you there, sir? Let me see if Sachugo is there. Hello, Sachugo. Hello? Hello, are you there? Oh, I can't hear Sachugo. Okay, so let me just go ahead and read the question in the chat window. So Emmanuel said, is there a way we can have this? not for now. No, not for this one. Not for now, Emmanuel. There's a reason for that. What will happen if I already have data encrypted in storage and delete the KMS later? Oh, that's not good, look, man. So your data essentially is gone. If you ever lose those encryption keys, your data is gone. So keep that in mind. So you don't ever want that to happen. So you want to protect who has the permission to be deleting keys in KMS or who has permission to be deleting KMS itself. You want to really protect who have those types of permission. So James says, is there a backup for lost keys? So I'm thinking by lost keys, you mean accidentally deleted keys, right? So there is a recovery period if you accidentally delete a key. There's a recovery period where you can recover your key. But once the recovery period is over, the key is gone, and that's it. So if you wanted to, you could implement some type of backup for your keys. So you can implement some type. So for example, like AWS, for example, recently, not recently, actually, it's been a while now, they support something called multi-region keys, which allows you to synchronize your keys into other regions in AWS. So there are other things that you can put in place in terms of for backup and for disaster recovery. But by default, backup doesn't happen by default, right? So all you get is a recovery period. And I see Manda says, wow, that's mad. I'm assuming that's referring to the 1 year policy. So yeah, so if you wanted something shorter, you can implement it by yourself. Let's see. So Prabhakar says CMK lowers days configuration period. What do you mean by configuration period, Prabhakar? Do you mean the rotation? If it's the rotation that you're referring to, if it's AWS managed, then that is 1 year. But if what you mean by configuration period is something else, you just let me know. So let's see. Prabhakar says data gone means unrecoverable permanently. Yes, unrecoverable permanently. And you will receive these warnings when you're reading the documentation, when you're reading, even when you're working in the console, to say this could potentially mean you're losing access to this data. If you're getting rid of this key and the data still being encrypted using this key, it could mean you're going to lose access to that data permanently. And even AWS can't help you, right? So James says, does KMS work with all AWS services? Well, not all AWS services need to use KMS. But the key services that needs to use KMS are services that we use for storing data. So services like RDS, S3, like DynamoDB. So those typical services that we use for storing data, from what I'm aware of, almost all of them support integration with KMS. So S3 supports server-side encryption KMS. DynamoDB supports the same. So for the services that we can use for storing data in AWS, from what I'm aware of, almost all of them support integration with KMS. So Prabhakar, I'm still trying to get what you mean by, because you said configuration period. So can you just help me to understand what that configuration means? Configuration period for what? Okay, so let's see. So Lukman says, is KMS service a free service? Well, there's some free tier usage, but it's not a free service. So you pay by the number of keys that you're storing and by the API calls that you're making to the service. So it's not free. I'm still trying to understand what Prabhakar means by that. Okay, so maybe we can chat up on something. I'm still trying to understand what that configuration. What does that configuration mean? Do you mean configuration of rotation or configuration of if you delete it? or configuration of what? So that's what I'm trying to get. Okay, so Okonkwo asks a very good question. Is AWS KMS service regional or global? It's a regional service. So it's a regional service. It's currently, as far as I'm aware, it's available in every AWS region. So, but it's a regional service. So there's a feature called multi-region keys that allows you to synchronize keys out of KMS in one region into KMS in another region, but that's something that you need to go pay for and that you need to implement as an addition. I'm looking at the time here, so let me move on quickly so we can conclude the next two topics and we'll come back to the questions again. So, Cloud HSM. Let's talk about Cloud HSM very quickly. This is another service that we can use for managing encryption keys in AWS. KMS has a key store that it uses. So KMS has a key store. The key store that KMS uses, that key store is validated for FIPS, which is Financial Information Protection, stipulations or whatever that S means. So essentially, it's like a compliance standard for financial industry. So that key store is validated up to FIPS level 2. That may not be sufficient for many organizations. They may require a higher compliance level. So for example, especially if you're working with a financial institution like a bank, or if you're working with maybe like a military institution, in some cases, they're going to require more stronger compliance requirements, and KMS may not meet that. So for example, the underlying key store that's used by KMS, it's multi-tenant. It's shared with multiple AWS customers. Maybe that compliance requirements require you to have a dedicated key store that is not shared with other customers. So KMS doesn't meet your requirements in that case. And apologies, this should not say KMS, this should say Cloud HSM. So this is where Cloud HSM comes in to help us. Cloud HSM gives us dedicated hardware appliance to store our keys and to perform our cryptographic operations. So not shared with any other customer, right? So also, Cloud HSM is more tamper resistant than KMS. So if I ask you, if you're like, let's say somebody is like an experienced hacker, and I, say attack this application, that's a skill that you need to attack an application, right? However, if you're going to be attacking a hardware module, it's a different type of skill that you need to attack a hardware module, right? So it's more tamper resistant in terms of that. So essentially, if your organization needs to be able to meet more stronger compliance requirements, you can look into Cloud HSM. So the keys in this case, they are managed only by the customer. So you can't get AWS managed keys in this case. So how does Cloud HSM work? To use Cloud HSM, we need to create something called a Cloud HSM cluster. Cloud HSM cluster. And we can decide how many appliances we want in that cluster. You can see here that we can have up to 28 appliances in that cluster. And you can see that these appliances are going to be connected to our VPC, to our private network. So that means we can use things like network security groups or network access control lists to manage network access to our Cloud HSM cluster. But it's also important to note that it is our responsibility to design our Cloud HSM cluster to be highly available, because now AWS doesn't manage that for us. It's our responsibility to do. So this is the minimum recommendation that's recommended. Minimum recommendation is have 2 Cloud HSM appliances across multiple availability zones. So this is what this is. So you have AZ1 and you have AZ2. So distribute your cloud HSM instances across multiple availability zones and then put them in a cluster, and then your application can essentially access them through a single endpoint, right? So that's the idea behind that, but that's your responsibility to do. How cloud HSM works in terms of the separation of duties. Here is how, what we need to understand. So when we're using cloud HSM, we have the HSM appliance, which is the hardware appliance itself that's dedicated to us. And within the HSM appliance, we can have HSM partitions. So these are the partitions where we're going to be storing our keys. AWS manages this, the appliance. AWS has access to this, the appliance. But AWS does not manage the partitions, and actually, AWS has no access to the partitions. So this is like a similar concept to if I give you the key to a room, does not mean that you have the access to the safe inside the room, because the safe inside the room has a different lock, right? So AWS has the key to the room to manage, firmware updates, maybe things like maintenance activity on the appliances. They manage all of that. They have access to do that. However, do they have access to go open the safe in the room? No, that requires a different key that only one person has, the customer. You control the key. You control the crypto operations. AWS has no access to that. David, does that mean AWS cannot do any damage? Because now they don't have access to the partitions. There's no damage that can be done. Of course, they can do damage. Damage can still be done. So a good example of that is the AWS, the HSM appliance that AWS manage. If let's say someone at AWS, or let's say their automation system goes wrong, and all of a sudden their automation system reinitializes the appliance. That's not good. Reinitialization is like doing a reset. And when you do a reset, what happens when you do a reset? You lose everything inside that appliance. So damage can still be done. But what happens is that AWS, there's going to be like a backup. So the information is automatically backed up on a daily basis. So in the case where something like that happens, then AWS can essentially help you to recover using the backup, right? So just keep that in mind. Okay, let's move on very quickly in the interest of time. So there's another option that's possible with Cloud HSM, which is called custom key stores. So custom key stores allows us to integrate KMS with Cloud HSM. So the whole idea behind that is I want the flexibility and the convenience of KMS. So I want the flexibility that KMS gives to me, and I want the convenience that KMS gives to me. Like the question that was asked earlier, KMS has integration with all these services like S3, has integration with DynamoDB, has integration with all these services already. So I want this flexibility. However, I also want the compliance, the higher compliance level that Cloud HSM gives to me. So what I can do is I can say to KMS, when I'm generating my CMK, I can say, actually, you're going to be using this Cloud HSM to generate the CMK and to manage the CMK. So I get the compliance plus the flexibility. So best of both worlds, essentially. So we have more control over the keys because the keys are going to be stored in our Cloud HSM, which we control, as we saw earlier. You want to consider using Cloud Store, using custom key store, which is essentially integrating KMS with Cloud HSM. If you have a requirement that your keys should not be stored in a shared environment, maybe you need to be able to meet FIPS level 3 requirements, then you want to consider custom key store. So this is what custom key store looks like. So in this case, you have KMS instead of our CMK is going to be generated here. And our cryptographic operation is going to be performed here. So this is just like a proxy. This becomes like a proxy to this essentially. So let's compare these three options very quickly. In terms of tenancy, KMS is multi-tenant. Cloud HSM, and if you're integrating it with KMS, that's single tenant. In terms of compliance level, KMS key store, FIPS level 2, Cloud HSM, and because you're using Cloud HSM here with custom key stores, that is FIPS level 3. The primary key, which is essentially the primary key CMK, that's managed by the customer only. In KMS, that's managed by KMS. In the case of combining both of them together, integrating them together, so we manage the Cloud HSM part, AWS manages the KMS part. We can use any one of those options to perform both symmetric and asymmetric encryption. High availability for KMS, it's managed by AWS. We manage it for Cloud HSM. If we integrate both of them together, we manage the Cloud HSM part, AWS manages the KMS part. In terms of regional availability, so this question was asked earlier, KMS is currently available in all regions, right? Cloud HSM is only currently in selected regions. And in terms of pricing, we pay per hour for the number of appliances that we've implemented. In terms of pricing here, we pay for the number of API calls that we're making and the number of keys that we're storing in the key store. And then in this case, it's both, right? We pay for the appliances and we pay for the API calls because we're integrating both of them together. So before moving on to the final one, I think that I've run out of time, so I may need to stop here for today. But let me see if there's any questions. So let's see. So few questions. So Conco, is the AWS KMS service regional global? So I think we answered that already. So it's regional. So James says, like if I wanted to access a bucket and it's encrypted, I could call on KMS through the SDK. That's for calling the KMS through the Lambda. How do I get the encryption? So that's essentially what you do. So you call on KMS. So you have a client application, James. Your client application wants to do client-side encryption. So what you can do is, let's say this is running on a Lambda function, right? So let's assume that this is running on AWS Lambda, right? This is a Lambda function. So you've given that Lambda function a role, and that role has permission to create data keys or to generate data keys in KMS. So what your application can do is make a call using the role to KMS to generate a data key, and then retrieve that data key to encrypt data before storing that data in S3. So essentially, you have to undo that from your application in terms of making the call to generate the data key that's going to be encrypted using the CMK in KMS, and then retrieving that key and using it to encrypt. And then if you want to decrypt that, you have to make the call from your application to retrieve the key in KMS and use it to decrypt the data. So hopefully that makes sense. So Lukman asked, Cloud HSM sounds more complicated. Can you share a link to learn more? Yes, so I will share some information. So it's actually not complicated if you think about it. So it's just dedicated appliance. So it's like KMS. So for KMS, you're using shared appliances with other customers. So but in this case, you have a dedicated appliance that's not shared with any customer. So this is a dedicated physical appliance for generating encryption keys, right? So that's what it is. So, and by the way, if you want to find out, so if I just do, so HSM hardware security module, I'll put a Wikipedia article in the chat window, Lukman. So review that Wikipedia article to see more about HSMs, and then hit me up on LinkedIn or something. I'll share some other links with you on that, on Cloud HSM. So Ismail, can you give us example of the name of the HSM hardware? Tell us some more, please. Yeah, there are multiple ones. So actually, I'm not too sure like which one, which HSM is used by AWS, but I won't be surprised if it's the N-Cipher one. So N-Cipher are very popular HSM companies, HSM organizations. So they create hardware security module. So actually, let me see if I can share my screen to sort of like show you an example of an N-Cipher one. So let me stop sharing, and this time around, let me share the whole screen. And and let me share the whole screen. Okay, so let me go ahead and bring up, so N-Cipher HSM, for example, this is what that looks like, right? So if you have a look at this, I'm not sure why that's not showing. Let's try that again. Let's share my screen again. Entire screen is what I want, sorry. I wasn't sharing my entire screen. There you go. So here's an example of what a hardware, dedicated hardware security module looks like. So you can see the appliance that you can use to generate encryption keys. So, and they will have dedicated in the data centers that belongs only to you and your organization. So yeah, so like what Samson said, you have IBM, Entrust, F5, N-Cipher is another popular one. So seen many banks use this. So anyways, hopefully that answers the question. So let's go very quickly and then we can do our quiz. I won't be able to do the third one, unfortunately. So yeah, actually, thanks very much. Okonkwo actually shared that already. So Talis is another option. So it's another third-party option that all creates a system. So actually, I don't have the time. We ran out of time already to talk about Secret Manager. But actually, I'll just give you a quick overview. So I won't go into the full details. Let me just give you a quick overview before rounding up. So Secret Manager, this is mainly a service that we can use for storing and managing secrets. So I'm not going to go through all of these. So these are best practices for managing secrets. You want to make sure your secrets are stored in a central repository. You want to make sure you have auditing so you can see who is retrieving your secrets. Somebody says, David, is there any difference between a secret and a key? Yeah, there's a difference. A key is referring to an encryption key that's generated using a cryptographic algorithm, right? So whether that's using a cryptographic algorithm like RSA, or whether that's using other types of cryptographic algorithms that exist. So that's a key that you can use for encryption, encrypting data. A secret in this case is referring to just application secrets, right? So that could be things like application password, database password, API keys. All of those are considered to be secret. API key, even though it has the word keys, it's a secret because it's just like a password. Maybe a database password, database connection string. All of those are considered to be secret. So there's a difference between a secret and a key. This is generated using a cryptographic algorithm like RSA. Okay, so you want to ensure that you can rotate your keys on a regular schedule. You want to ensure that you have control of your secrets. So I'll just give a quick introduction. So Secret Manager is a service that we can use to essentially centrally manage the life cycle of secrets in AWS. So you want to store, so instead of putting those secrets in code, right? So you want to go to your application configuration file and you put your database connection string directly in code or in your configuration file. Or you want to connect to an external API and you put that API key directly in code or in your config file. You don't want to do that. What you want to do is you want to decouple your application secrets. You want to decouple them from the application itself so that, number one, you don't accidentally go commit that into source control. Number two, you can manage them much more securely over here. So Secret Manager is a service that we can use to do that. So I won't go any further because we ran out of time. So I'll just skip through this. But guess what time it is? It's time for quiz. And today we have two prizes. We have the first prize is going to be a credit voucher, and the second prize is going to be a credit voucher. And we have a few questions mainly on KMS today. So see who has been paying attention. So what you want to do, if you go over to www.kahoot.it, so go over to www.kahoot.it, and I will give you a PIN number in a minute, and you can use that PIN number to connect to, you can use it to connect to the quiz. So it is coming up. So let's go. So here is the PIN number for today. The PIN number for today is 647507. 6475507. So let's quickly get this done. So www.kahoot.it 6475507. Again, the rules of the community still applies. You have won a gift previously in this series. You cannot win twice. This series is coming to an end next week, so you'll be able to win more after that. So, but for this series, you can only win once. So I'll just give it a few more seconds, and then we're going to get started. So we have two prizes today. So number one and number two are going to be getting prizes. Okay, let's go ahead and let's get started. Let's go ahead and get started. I'll go ahead and kickstart this. Let's get started. KMS and Cloud HSM. Oh no, James, I'm not sure what happened there. Question number one. The key material in a CMK has been imported. You need to rotate the key material every year. What should you do? Emmanuel, that is www.kahoot.it. So if a lot of people have joined, so I'm not sure why it's not opening on your system, because I can see we have like about, let's see, we have a lot of people that have joined already. So I'll say check your system if it's not connecting. Yeah, I can see Okonko said it's going from his end, yeah. So I'll say check your system, Emmanuel, if it's not connecting. Let's see. The key material in CMK has been imported. You need to rotate the key material every year. What should you do? Remember, in this case, if the key is imported, you cannot use automatic key rotation. Automatic key rotation is if the key is managed by AWS. If the key is imported by you, then you have to be responsible for the rotation, which means the process that we went through, the three-step process. You have to create a new CMK, and then you have to change the alias to point to the new CMK, and then you have to change the policy for the old key, and then you have to disable the old key when you're done. So if you need a refresher, just rewind back on YouTube later on, and you'll be able to see it. So let's see what the scoreboard looks like. So we have Lucky and one day, so well done. So question number 2. This is a multi-select. Which statements below describe the characteristics of a KMS customer managed key? So I'll give you a tip. There are two answers. There are two answers for this one. There are two answers. Oh, and lots of people got the first one correctly, and 4 people got the second one correctly. So why is this one not the answer? CMKs cannot be exported out of KMS. CMK, keep in mind, repeat it to yourself if you need to. CMKs can be exported out of KMS. CMKs can be exported out of KMS. So CMKs can be generated by AWS themselves if that's the option that you've selected. You can go ahead and you can import them if that's the option that you've selected, in which case you manage the rotation by yourself. In this case, you can do auto rotation. So can you re-import a key material into a CMK? So the answer to that is no, you can't do that. You can re-import the same key, but you can re-import a new key. Essentially, you have to create a new one. So let's see what the scoreboard looks like. And it changes. So we have one day, Lucky, Fabu, top 3 question. Which security method used by USKMS is best suited for an AWS service that needs key access for temporary use? So we talked about this earlier. Temporary use. Okay, lots of people got that correctly, and that makes me very glad. That means you listened. So well done, everyone. So let's see what the scoreboard looks like. We have one day, Lucky and Prabhu. So well done, well done. Number 4. So this is a multi-select again. The key material in a CMK has been imported by a customer. Which configurations can be performed on the CMK? It's been imported, keep in mind, not generated by AWS. So there are 2 answers there also. There are 2 answers. So let's see. So that's really, really good. Well done. So remember, we talked about this a few seconds ago. Automatic key rotation is only for when the CMK is managed by AWS. When you import the CMK by yourself, you manage the rotation, not yourself. Sorry, not AWS. So you cannot do automatic key rotation in that case. You have to go through the 3-step process that we saw. So that takes that out. This one is also out because you cannot export the CMK. So by means of elimination, you eliminate that one because you can't do automatic key rotation for keys CMK that where you've imported the key material by the customer, and you can also not export that. So the only 2 other options are these 2. So let's see what the scoreboard looks like. Oh, and we have a few changes there. We have one day Teddy Lucky in our top 3. So let's see. Number 5, true or false, both KMS and Cloud HSM are multi-tenant. Awesome. So that's false. So these ones, essentially the next two questions are going to be similar to this. So they are true or false questions. So KMS and Cloud HSM. So KMS is multi-tenant, Cloud HSM is single tenant. It's dedicated appliance for you. So that's false. So scoreboard. We have one day, Teddy, Abdulatif, top three now. So Prabhu is creeping up back again. Yeah, and so it's intentionally too fast, Lukman, because they are just short ones. So these ones are going to be short going forward. We have two more, and they're going to be short. Essentially, it's like yes or no, true or false. So that's the reason why. So let's go to the next one. True or false, both KMS and Cloud HSM are FIPS 142 compliant. And the answer to that is true. They are both FIPS 142 compliant. Only that KMS is FIPS 142. KMS is FIPS 142 level 2 compliant. This is level 3. So, but they're both FIPS 142 compliant. So, let's see what the scoreboard looks like. Oh, we got some changes there. We have one day, Teddy and Abdulatif still top three. And then we have the final question for today for our prizes. Both KMS and Cloud HSM has HA automatically implemented by AWS. True or false? And that is false. So for KMS, HA is automatically implemented by AWS, but for Cloud HSM, HA is managed by the customer. You have to make sure that you have two appliances across multiple availability zones. You can choose not to implement it in that configuration, but that's not recommended because again, if you lose access to one of them and you've encrypted data using the keys, then you won't be able to access that data. So let's see what the scoreboard looks like, and then we're going to see what our prizes are like. So let's see. On the podium, number 3, we have Abdulatif. Well done, Abdulatif. Number 2, we have Teddy. Well done and congratulations, Teddy. And number 1, we have one day. Well done. Awesome. So one day and Amwaf Prabhu was number 4, and then we have someone else about his name. So one day and Teddy, congratulations to you both. So if you send your full name and email address to the email I just put in the chat window, awssecwestafrica@outlook.com. So, and then we'll do that. So remember, you can only win the prizes once in the series. So if your name comes up that you've won a prize before in this series, then we'll have to give it to someone else, number 3 on the list or number 4 on the list. So congratulations again, Wande and Teddy. And thanks very much, everyone, for joining us. Next week is the end of this series. So next week, we have the final 2 sessions on this series, and that'll be the end of the series. So thanks very much for joining us. We're going to see you next time. Have a lovely, lovely rest of the day. So congrats again, Wande and Teddy. Well done. Thanks very much. Congrats. Okay, see you next week. See you next week, everyone. Bye for now.